working on. All right, reviewing and utilizing powers of exponents. Okay, in lesson 1. Lesson 2, adding and subtracting polynomials, combining like terms. Lesson 3, learning to multiply or distribute polynomials within one another. And then 5, 6, 7, learning the different methods of grouping comes all down to lesson 8. All right. What lesson 8 is we are solving equations by using the zero product rule, meaning all of the polynomials we've been covering, all right, if we set them to equal 0, what numbers can make our polynomial equal 0? What that means is if I throw this on a graph, okay, what numbers along the y-axis am I going to have to put a dot on and then create my parabola? All right. So here is our standards. Our essential question is, how do you solve equations by using the zero product rule? The lesson objective is I can identify the intercepts of polynomial equations and use them to construct a rough graph of the function. So we're going to find these sets of numbers, all right, that cross the y-axis, and then we are going to make a rough graph of that function. So what we've been working on is all of these are quadratic equations, meaning if we throw these in a calculator, all right, it's going to make what's called a parabola. This is positive, this is negative. All right. If for whatever reason this is wrong or this is wrong, as we solve it, it could, in terms of technology, it could cause your phone to have a complete meltdown. All right, because one wrong number, all right, can make the picture go too big, too small. The program won't load. The social media, Facebook, Twitter, Instagram, Snapchat, TikTok, nothing will work properly if something basic like this is freaking out. Okay, so if you notice, all of these are equal to 0. Just kidding. They're all equal to 0. To go from here to here, here to here, here to here, all right, we're setting it equal to 0, meaning we're moving this number, distributing this out, then moving this number, distributing this out, then moving this number. Okay? In order to move said number, in order to move this number, you're going to do the opposite sign. All right? So if it's a positive 1, you are going to do to both sides a negative 1. You're going to subtract 1 from both sides. Okay? You're probably thinking, but Mr. Reed, why can't we just get rid of the number? All right? Here's why. If we just forget about the number, it just goes off into the sunset. Your phone, your computer, any technology you have, if one little number is off, it will not work properly. I can promise you. All right? Believe it or not, one little number is off. Everything you enjoy using, everything you enjoy, you think you can't live without, it will not work. Okay? And in order to move across, so what we have to do is we have to pretend this equal sign is a wall. We have to pretend it's a wall. So in order to move it from here, this side to this side, all right, you have to move it either by addition, subtraction, multiplication, or division. All right. What you do to one side, you have to do to the other. In terms of science, for every action, there is an opposite and equal reaction. Keep that in mind. So to move the -1, or to move the +1, we're going to do -1 to both sides. They cancel. There is no other little non-variable term, non-variable number, so he becomes part of the equation. For this 3, +3, so we're going to do a -3 to both sides. Okay. They cancel. X, once again, no non-variable number. All right, so he becomes part of the equation. This one's a little different. +9, so we're going to subtract 9 from both sides because we have our wall. They cancel. Hey, look, we have a non-variable number, so we're just going to combine like terms. -16 minus 9 gets us a -25. All right. So once again, okay, we are going to actually solve these equations. All right. The zero product rule states that if the product of two factors, okay, is 0, then one or both is equal to 0. Let's take a look at an example. Okay. So we have 2x squared minus 5x equals 12, which, all right, first things first, we have to get this equal to 0, which means we're going to move this happy little 12. In order to move this positive 12, we are going to subtract. All right, we have our little wall. They cancel. All right, there's no other constant non-variable number, so he just becomes part of the equation. Oh. Okay. Now, if you recall from the AC method, when this number is not 1, we have to multiply him with the C term and then utilize the grouping method to figure out the two factors. All right. So when you take this 2 and you multiply it with -12, we get a -24. All right. But I'm not going to worry about the negative right now. We're just going to worry about 24. So we're going to list all the factors. The numbers that, when they're multiplied together, get us 24. 1 and 24. 2 and 12. 3 and 8. 4 and 6. Okay. One thing to remember when you're dealing with polynomials. All right. I've said this previously, but this is a simplified, quick, easy way to think of it. All right. If this is negative and this is negative, okay? If they're both negative, you're going to subtract. Reason being, all right, if the B term is negative and the C term is negative, if both of those are negative, we're going to subtract. Reason being is one number has to be bigger than the other. Or one number is going to be bigger than the other, all right, and that number will have either the negative or the positive regarding of where we go. If the middle term is negative and the last numbers, or if the middle term's positive and the last term's negative, we'll have to subtract again. All right, because this goes back to the whole one number will be negative, one number will be positive. Okay. If both are positive, we are going to add. And if the first one's negative, but the second one is positive, we're going to add. All right. So here's a quick little chart. This is the B. This is the C. Okay? And this is what the action is. Okay? So with that in mind, because this is negative, all right, this is negative and this is negative, we're going to follow that rule, meaning we're going to subtract all of these. We're going to subtract 24 from 1, 12 from 2, 8 from 3, 6 from 4. 24 minus 1, 23. 12 minus 2, 10. 8 minus 3, 5. 6 minus 4, 2. All right. Now, out of all of these, we're going to look at the one that equals 5. All right. He does not equal 5. He does not equal 5. He does not equal 5. These do. Okay. So now we're going to break -5 apart. Now, because it's -5, our 8, because it's the bigger number, will get the negative sign. So it's going to be 2x squared minus 8x plus 3x minus 12. Now we're going to use the grouping strategy, meaning we are going to group these two together and these two together. Now we're going to find the GCF of 2x squared minus 8x, and we're going to find the GCF of 3x minus 12. So the GCF is 2x squared minus 8x is 2x. Because 2 can be pulled from both, and you can pull an x from both. So when you yank 2x out of 2x squared minus 8x, you're left with x minus 4. Now we're going to look at 3x minus 12. We can pull a 3 out of both 3 and negative 12. So we're going to do 3. All right, which leaves us x minus 4. And if you recall, you're going to combine that and that. So 2x plus 3. And then you're going to use just one of these. Okay? So 2x plus 3 times x minus 4. What we have to do now is figure out, okay, what does x equal for both? So we're going to separate these two and set each one equal to 0 individually. So we're going to do 2x plus 3 equals 0. X minus 4 equals 0. All right. We'll do the easy one first. Opposite of -4 is a +4. And what we do to one side, we do to the other. They cancel. 0 plus 4 leaves us 4. We move the x. So x can equal 4. All right, let's take a look at this one. 2x plus 3. We're going to subtract 3 from both sides, which leaves us 2x equals -3. All right. And believe it or not, this 2 and this x are actually multiplying each other. All right, that is read 2 times x, and the opposite of multiplication is division. So we're going to divide 2 from both sides. They cancel, leaving x, which leaves us -3, 2. Okay, now, just out of curiosity, we are going to check to make sure this is right. So instead of x, I'm going to put a 4 squared minus 5 times 4 equals 12. All right. 4 times, and okay. So first thing we're going to do, 4 times 4. All All right, because you always do exponents first. 4 times 4 equals 16. 16 times 2 equals 32. 5 times 4 equals 20. 32 minus 20 equals 12. So 12 equals 12. So x equals 4. And if we did the same thing with this, it would end up equaling 12 as well. Okay. Let's take a look at it a little bit easier one. All right. So we have 6x squared plus 8x equals 0. All we have to do is pull the GCF out and figure out the 0. All right. Set it equals 0. Set each factor to 0, and away we go. So 2x can be pulled out of both. Okay. 2x can be pulled out of both. 6 divided by 2 leaves us 3. X squared divided by x leaves us x. 8 divided by 2 leaves us 4. X divided by x, they cancel each other out. So we're left with this and this. Now we're going to set each individual piece equal to 0. 2x equals 0. 3x plus 4 equals 0. All right. First things first, 2 times x. So we're going to divide both sides by 0, or 2. 0 divided by 2 gets us 0. All right, now we're going to do 3x plus 4 equals 0. We got to move this 4. All right, to get x by itself, so we got to get him all by himself before we can tinker with it. They cancel. 3x equals negative 4. All right, now we're going to do opposite of multiplication, which is division. They cancel. X equals negative 4, 3. So that is an answer. That is your answer. That's all you do. Now this one's a little tricky. All right, example number 3. Simply what you're going to do is distribute this out, then move all of this over here and set it to 0. And this one's really easy. All right. You're going to set this to 0, this equal to 0, that equal to 0, and that equal to 0. Okay. So that is it for lesson 8. The last 2 you will do on your own. Okay. And if you end up, if I do need to show you in class, that is perfectly okay. All right. Next time we'll begin preparations for the end of unit assessment. Then we will be moving on to unit 5. So we will see you for unit 5, rational functions.